This is a short video on the deductive reasoning process. We will look at the structure of deductive reasoning, some examples of deductive reasoning, and we will also cover some criticisms and some strengths of the deductive reasoning process. Deductive reasoning is a logical process where the conclusions necessarily follow from the premises. In other words, if the premises are true, the conclusion must also be true. This form of reasoning provides a certainty of outcome, which is very rare, and so it's useful to test hypotheses and theories. The fact that we can follow this logical process and say if the premises are true, the conclusion must be true, it is certain, makes it a very powerful tool for proving theorems. If we look for a common example everyone would recognise, we would perhaps use the Pythagoras theorem. If we know the sides of the triangle are a certain distance, we can work out the distance or the length of the remaining side. However, it's kind of rare where we'll have a situation where we'll know those premises in that level of detail, where we can rule out any other information or any uncertainties, which means we have to be very careful about the application of deductive reasoning. The key characteristics of deductive reasoning are that we start from general and move to a specific. So we have a general statement or hypothesis, we examine the possibilities to reach a specific logical conclusion. And that is a certain conclusion. Provided the premises are accurate, in deductive reasoning, that outcome is certain. And that's quite distinct from the probabilistic nature that we've seen in inductive reasoning. We're therefore relying heavily on a structured logical framework. And so we will have one or two premises. If we know for a fact they are true, the conclusion is undoubtedly true. There are some different forms or different types of deductive reasoning. The first being a syllogism, a form of reasoning where the conclusion is drawn from two given or more propositions, premises. For example, all birds have feathers. Penguins are birds, therefore penguins have feathers. Sometimes we can add in some conditions, words like if or then, to make a statement. For example, if it rains, the ground will be wet. It is raining, therefore the ground is wet. So we can see there is a very common structure, a very unique style of writing that's applied to deductive reasoning. Another form of argument in deductive reasoning is the modus ponens, a form of argument where if the first statement is true, the second statement must also be true. For example, if it is a dog, it is a mammal. It is a dog, therefore it is a mammal. Very, very simple, very black and white, very structured. We can have the inverse of this, the modus tollens, a form of argument where if the consequence is false, then the conclusion must also be false. Sometimes you'll see different terms, such as consequence and antecedent, but essentially we're talking about the final conclusion and the premise. So if the conclusion is false, then the premise must also be false. So if it is a dog, then it is a mammal. It is not a mammal, therefore it is not a dog. So you can see that the first sentence is the opposite way round to the second sentence. The rigid structure that the deductive reasoning process relies on does raise some criticisms. The fact that there is this heavy reliance on the truth of the premises is often a point of contention. If there is any errors in those premises, if people believe something to be true that is not true, then they will reach a conclusion which is not true, regardless of how logical the structure of that argument is. Because we have to rely on complete knowledge, the deductive reasoning process does not generate new knowledge. It only clarifies what we know. That means that while we can have some certainty about what's been said, it doesn't contribute to the advancement of new ideas or discoveries. The structure in itself, which focuses on formal logic and structure, can sometimes overlook the complexities and nuances of real-world situations. It overly simplifies the summary of a situation, and that doesn't always sit well with people. Bringing in the complexities of reality makes models more complete than are compatible with deductive reasoning, and that is often accused of making an incomplete representation of reality. Life is complex. We can't simplify that process to make the deductive process work. For the sake of applying deductive processes, we can't ignore the complexities of reality. There is also a very big challenge with regards to dealing with the emotive side of life. If we look at ethical and moral reasoning, it can be very difficult to form simple, straightforward premises and conclusions when people have their own subjective opinions about the premises that are being put forward and the conclusions that are being drawn. And so deductive reasoning is incredibly hard to apply to situations like ethical and moral reasoning. Now that seems, in many ways, like we've heavily criticised deductive reasoning to the point when it almost has no value, which is no way to end a video. So let's look at some positive points. Deductive reasoning is highly reliable and precise when the premises are true, which means that in the situations where we need that level of precision, mathematics, philosophical logic, computer science, then deductive reasoning is highly valuable. It also forms a foundation for many areas of knowledge. If we can establish the parts that are fundamentally true, we can build upon that. And remember that reasonings don't have to happen independently. Deductive reasoning gives us this clarity and consistency in arguments that can provide a really good starting point to help us avoid contradictions and ensure that conclusions are logically sound. Once we have this basis, we can complement the process that we're going through, the thought process, the argument that we're constructing, by introducing inductive reasoning as well. It can provide that starting point for the inductive thought process to develop from. It also works very well in formal systems where precision and certainty are crucial. In legal reasoning, for example, deductive logic helps apply general laws to specific cases, ensuring consistent and fair outcomes.